Our objectives are to estimate the annual abundance and biomass of common prey species in the lake, as well as look at trends by developing some long-term time series for prey fish in the system. So we have two different surveys that we do. The first survey is the acoustic survey. This is a nighttime survey that employs fishery hydroacoustic technology as well as midwater trawl sampling to verify what the acoustics are showing on the fish finder. The map on the bottom represents the spatial coverage. This survey takes place in both the main basin, Georgian Bay, and North Channels. It's an annual survey. The bottom trawl survey is a daytime survey. Occurs a little later in the fall, and the method is to pull the bottom trawl on the bottom. The map on the bottom also represents the spatial extent of that survey. It's main basin only, primarily on the West Shore and Michigan waters, but we do sample Goderich as well in most recent years. So I'm going to start out talk about the acoustic survey results. As I mentioned earlier, this is a joint survey using the MV Spencer Baird of the Fish and Wildlife Service and Steve Leonard and his crew helping with a lot of the sites in the northern part of the main basin. And the USGS does the rest of the main basin, Georgian Bay, and the North Channel. The survey this year occurred from September 8th through the 29th. They sampled 26 different transects and conducted 37 midwater trawls. As you can see on the map there, the yellow dashed line represents the acoustic transects, and the green triangles represent where they conducted the trawling. This survey in 2015 covered depths ranging from 15 meters to a little over 200 meters. So I'm going to show a series of graphs that are all pretty much set up the same way. On the top is a density estimate on the y-axis. These are numbers of fish per hectare, and the bottom graph is that numbers of fish converted into biomass and represented in kilograms per hectare. The x-axis is the different years of the survey. We did do a survey in 1997, and for alewife you can see that the abundance of alewife in 97 was quite a bit higher than what we've seen since 2004 through the present. It was a good year for alewife because we didn't catch any in the acoustic survey, and when I show you the bottom trawl, we caught very few there as well. Since 2004, only about 2% of the pelagic prey fish biomass has been alewife. It's been very low for the last decade in offshore areas of the lake. Same type of graph here, but for rainbow smelt this time. The top graph is for young of the year, age 0 fish only, and that's the density numbers of young of the year caught, and the bottom graph is yearling and older fish. We saw an increase in young of the year between 2014 and 2015 of about 50%, and this represents about 66% of the long-term mean in the time series. Point out also the 1997 values are much higher than we've seen in the last decade. Yearling and older decreased from 2014, and the 2015 value represents about 50% of the long-term mean. Bloater chubs, same setup here as with the rainbow smelt, young of the year on top, yearling and older on the bottom. We saw a 9-fold increase in age 0 density from 2014. That represents the second highest in the time series for young of the year bloater. You can notice in 1997 there is a dot there. Young of the year bloater were very rare in 97. Compared to yearling and olders, which was the highest we have in the acoustic time series. In 2015, we saw a small increase in bloater estimates based compared to 94, but they're still very abundant throughout the main basin. So this is lake-wide density and biomass for all three of those species added together, and this does represent all three basins, as did all the previous graphs, main basin, Georgian Bay, and North Channel all combined. The mean density of fish was 1,313 fish per hectare. It's about 77% of the long-term mean. It was up a little bit from 2014, as was the standing stock biomass, about 50 kilotons in the acoustic estimates, and that represents a value of 92% of the long-term mean. but notice that the 97 values are much higher. So here Tim broke these out by basin. These again are stacked columns of the prey fish biomass for alewife, rainbow smelt, and bloater. You can see that 97 value sticks out as very high in almost all the basins except the North Channel. Alewife represented more biomass in 97 than it has in the last 10 years. A majority of the biomass is made up by rainbow smelt and bloater. In Georgian Bay, we saw a decrease in rainbow smelt. Main Basin, bloater increased, as did young of the year smelt. And the North Channel, we saw a decrease in both smelt and bloater. They do catch Cisco, large-bodied Cisco in this survey. We've had this question asked in previous years, so we thought we'd throw this figure in. The white dots on the map just represent the sites where Cisco have been collected in both the acoustic and midwater surveys, as well as the bottom trawl surveys. The two dots in the northern Main Basin here and at Hammond Bay here do represent catches of Cisco in our bottom trawl survey, although they're very rare. A total of 111 Cisco have been collected across the lake since 2004. So now I'm going to shift over to the bottom trawl survey. This map represents our fixed site stations. Our depth range from 9 to 110 meters, although not all depths are represented at each port. 2015 was our first year using the new RV Arcticus for the Lake Huron survey. We were done in record time for my tenure on the survey, which has been 12 years now. Took us 2 weeks. We had no issues with weather or gear when we sampled all our ports. So I have a similar setup to my graphs as the acoustics graphs. The y-axis represents abundance in numbers per hectare on the top, and I have them broken out by young of the year and yearling and older fish. And on the bottom, we've converted that into biomass for both young of the year and older fish. And these are the alewife. As you know, these fish collapsed in 2004, haven't rebounded at all. 2015, we collected no yearling and older alewife and only 24 young of the year for the entire bottom trawl survey. Our size distributions of alewife have been skewed towards the small fish for quite a while now. Very rarely do we see a large alewife, and when we do, it's usually in the northern part of the lake. The 2015 fish were all young of the year, less than 90 millimeters. Rainbow smelt, we have the time series extending from 76 up through 2015 here. Same graph design on all these slides I'm going to show. 2015 we saw a decrease in both young of the year and young of the year abundance and biomass, and also a decrease in yearling and older abundance and biomass, representing some of the lowest levels of rainbow smelt we've seen. Size distribution of rainbow smelt, again, is skewed towards smaller fish. We see only a handful of fish in the large category, and we have seen them up over 200 millimeters in the survey, usually down in the southern Main Basin, Goderich and Harbor Beach. Every year there seems to be an unusually large rainbow smelt caught down there. But the majority of the fish are very small, young of the year. Bloater has been our kind of savior for the last decade or so since alewife collapse. As you can see in the young of the year graph, we've had some really strong year classes hatched in both numbers and biomass of those young of the year fish. These did translate into some yearling and older fish. However, the absence of large bloater still remains a mystery. Carson is going to talk right after me with a lot more detail on the history of the bloater size, age, and growth composition in the lake. But for the last decade, we've had mostly small bloater with very few large-bodied bloater that folks like to smoke and eat. The benthic sculpins, 2015 we caught no slimy sculpins. Slimy sculpins have been rare in our catches for a decade or more now. We did get some deep water sculpins, just a minor increase over the 2014 value, but again, both sculpin species have been very rare in our survey. Nine-spine stickleback and trout perch, also very low abundances. We did see a minor uptick in the nine-spine sticklebacks in the bottom trawl survey this year. Trout perch showed up at almost all ports that we sampled, but they're in very low abundances. Round goby, we've kind of seen these guys peak in the early 2000s and then declined, and another peak again in 2011 or so, and then another decline, and a slight increase in 2015 from the 2014 value. But I know everybody knows there's been a lot of discussion and speculation about how well, but gobies were in relatively low abundance. We do get them in all ports, and we've caught them out at to 82 meters depth to replace them. But then we did see some increase in young of the year and yearling and older bloater chubs. And we're back down to a low level again in 2015. Overall, this is the third consecutive year of a decline in lake-wide biomass based on bottom trawl catches. We're at 19.4 kilotons for the lake, about half of the estimate in 2014, so a dramatic decline. This is our second lowest biomass level. 2009 was our lowest, and this value here represents about 5% of what we saw in 1987 with 368 kilotons. Our overall trends in the lake from both surveys, the acoustic survey and the bottom trawl survey, show that alewife are almost absent in our surveys. The acoustic survey caught 0 in 2015. Bottom trawl survey only caught 2 dozen. Rainbow smelt are low in the main basin based on both surveys. They're higher in the North Channel and typically are in most years. Bloater remain the dominant prey type. End of the spectrum. I'd like to thank our support crew, our vessel captains and crew, technicians, and our science support team and IT team at the Great Lakes Science Center for help with data processing. Thank you for your attention.